Hi, I'm Chris with Sanderson Test Prep, and in this video we're going to talk a little bit about related rates. So a few of my calculus students this fall have started getting into related rates in their classes and asked me a few questions, so I wanted to answer a question that was posed by one student, and it was a question that dealt with a person and a rocket. And so let's read through this question and we'll talk about how we would approach this using related rates. If you're not sure what related rates are, or if you haven't yet done implicit differentiation, then I would take a look at one of our other videos on implicit differentiation, because that's the starting point for understanding how to approach a related rates word problem. But if you're already getting into related rates word problems in your class, then this is a perfect type of question for you to look at so that you can benefit from our analysis of how you want to approach these. So this question says a person is standing 350 feet away from a rocket that is fired straight up at a rate of 15 feet per second. At what rate is the distance between the person and the rocket increasing 20 seconds after liftoff? So let's take a look at the key information that we have here. And for each, we want to understand if we're looking at a set value or if we're looking at a rate, which means something, when it has a rate to it, it's going to be something per something. Most of us are familiar with miles per hour. When you drive, you're driving at a rate. So it is a distance over a time. So in this case, we have 350 feet given to us. That's a set value. We have a rocket that is moving straight up at a rate of 15 feet per second. So that's definitely a rate. That is a change in distance over time. And then they want to know at what rate is the distance between the person and the rocket increasing 20 seconds after liftoff. So 20 seconds is another set value. We're looking for a rate, which means our answer should be in feet per second. And let's see if we can get into the calculations of it here. Okay, so we're talking about a person and a rocket, and the rocket is moving straight upwards, and then they want to know about this distance between the person and the rocket. So we're looking for the rate of change in our hypotenuse of this triangle. And if we have a right triangle, what is a theorem that we know that relates the sides of a right triangle? So hopefully, if you're taking calc, you're very comfortable seeing a right triangle and automatically jumping to Pythagorean theorem in your mind. And that's exactly what we want to think of in this case. And Pythagorean theorem is, so hopefully you said a squared plus b squared equals c squared. If you didn't, then I'll tell you right now, you need to take a couple steps back and really solidify some of that geometry knowledge before we jump into a difficult calc question like this. But if you're comfortable recognizing Pythagorean theorem, then we can get into the calculus of it. And the first part is we want to see if we can derive this. And in this case, it's going to be a form of implicit differentiation, because everything that we see here is in terms of time. We're talking about per second. And if we're looking at it per second, then that means that here, when we derive this, we have 2a, but then times you have the derivative of a, which is dA dt. So that is the change in a over the change in time, or the derivative of a in terms of time. We're going to see the same thing for b. That'll be 2b times dB dt for the derivative of b, and it's going to equal 2c times dC dt. So these derivatives, remember what derivative means conceptually. This is probably something, if you're taking calc now, you probably learned it about a month, maybe 6 weeks ago. But if you're looking at these changes, your derivative really means it's a rate of change. It is the slope of the tangent line at a particular point on a graph. And so these are your rates of change for each. A, B, and C are the set sides of that triangle. Let's see if we can plug in our values here to solve for each. So first, if we take a look for A, this height, do we know this height? Well, maybe. They don't give it to us directly in the question, but they give us enough information to tell. If we're moving at 15 feet per second, how far have we gone after 20 seconds? So to figure out A, a little side calculation here, A is going to equal 15 times 20 to give us 300. So we do have a value for A, and that's the tricky part about related rates questions, is that typically speaking, when you set it up, if you only look at the values given in the question and you don't calculate any missing values, then usually you're one value short. And for a question like this, you would look at it and say, well, hold on a second. For A, I don't really see a value for A given in the question. They don't tell me the height of the rocket, but they tell you how long that rocket has been moving upwards at a rate of 15 feet per second. So we get that A is 300. dA dt, so how fast is that rocket moving upwards? This they give us right in the question. That's that rate of 15 feet per second. That is your rate of the height of the rocket as it is fired straight upwards. That is the rate of change in that height as the rocket moves in an upward direction. So that is going to be 15. And then we're going to add on that 2 times b. B in this case, this distance between the person and the rocket. Well, if we look in our question, do we have any set values that tell us the distance between the person and the rocket? So we do. That set value is right up here at 350. So that would be 2 times 350. And this is the fun part of a question like this. I know, it sounds weird to say fun when we're talking about a related rates question, but this is the fun part. That's 350. Now, dB dt is the rate of change in this value. From where the person is standing to where the rocket took off, is that distance changing? Is there any movement horizontally there from either of those? The rocket took off and is going straight up vertically, but that launching point stays the same. The person is standing in the same place. So here, your dB dt is going to be 0. That's going to work out really nicely when it comes to the math on this. It's going to help simplify that quite a bit for us. And then on the other side, we have 2, and then we have c, and then we have dc dt. And dc dt, this is what's being asked for. This is the unknown rate. What rate is the distance between the person and the rocket increasing 20 seconds after liftoff? So that means that c is something that, again, they don't tell us directly how far that is at that point, but they do give us enough information to calculate it. For any triangle, if I know one side is 350 and one side is 300, can I solve for my missing side? I can, and this is just a little bit of Pythagorean theorem here. I'm going to sneak the calculation in down here so that we can finish this out with enough room over there. But here, for Pythagorean theorem, simple Pythagorean theorem on this, a squared plus b squared equals c squared. C is going to end up equaling the square root of, that comes out to 212,500 for C, which is, it's about 460-ish, 461. It's, I think, the exact value is 460.977 and change for C in that case. And that's what we can plug in here. It's 460 point, we'll go point, I think it's like 779 something something. And then from there, if we rearrange everything and solve, so when we divide by this term, the 2's will cancel if you want to economize that calculation a little bit. And what you end up with over here is 15 times 3 is 45 with the 2 zeros. That would be 4,500 over 460 with your decimals. And that is going to come out to a grand total of about 9.76. And depending on your class and your teacher, you can carry it out to as many decimal places as needed for any of those individual calculations. I'm just ballparking it from here, but the main takeaway is that when you have a related rates question, you're going to have a couple key steps. And I want to jot down these couple key steps over here. So the first is for a related rates question, and it sounds silly because it almost seems like it's too easy, but figure out what shape you're looking at. Usually in a word problem, they don't tell you this is a triangle or this is a sphere or this is a circle. They're just going to describe a scenario, and you have to be able to convert that scenario into a visual image so that you can really see what shape you're dealing with. Once you have the shape, then the next step is you're going to figure out the equation related to that shape. So in this case, for a right triangle, we're dealing with Pythagorean theorem. So that's what we do when we know a couple sides of a triangle. We're looking for a missing side. We know we're dealing with Pythagorean in this particular case because we know our shape is a right triangle. And then the next step is to derive. And that's what we did here. So we took the derivative of this to get this nice big long equation here of the 2a dA dt plus 2b dt equals 2c dc dt. And then the easy part, hopefully, the hard part is setting it up, but once we get there, we're just plugging in those corresponding values. So we plugged in for a, we plugged in for dA dt, we plugged in for b, we plugged in for dB dt, we plugged in for c, and then we were able to calculate dC dt, which is the rate of change that they were asking about, which is the rate of increase in distance between the person and the rocket as the rocket is accelerating, or not accelerating rather, as the rocket is traveling upwards on that. If you have questions, please feel free to comment below. Otherwise, like and subscribe, and stay tuned for more videos.